Hello everyone. So in this video I will be touching on or discuss the idea of areas of rectilinear figures catered in IGCSE Additional Maths, Chapter 7 in Supplementary Textbook. So it bears the question, um, how do we find the area of any random rectilinear figure? But then before that, let me just touch on a bit of what it means by rectilinear figures, or what is rectilinear. From the meaning of the language, rectilinear, it's comprising of two words, rectus and linear. We know linear basically it's a line, straight line. Well, then rectus itself is not talking about either straight or right. So then whenever we're talking about figures of rectilinear, it's simply talking about any figures related to straight lines or made by straight lines. And then you might have guessed that it's related to basically polygons. But then it's a general shapes or general figures in the sense that it can also involve, it can be regular, and then in particular we will be talking about the irregular types of figures. So it is a general figures for any polygons. So for example, you'll notice here that there is a shape in a Cartesian plane that's in the shape of a triangle. There are three coordinates over here: x1, y1, x2, y2, and x3, y3. So to know how to find the area of the rectilinear figure, I put it in another handout. The idea for this, like the derivation of the formula, which we know later on as a shoelace, or in some resources they call it a shoestring method. So essentially there are two ways to solve this question or to find the area. Is that either by basic shapes, is that if you can see this, the idea is that I can create a big rectangle over here, then I can find the area of the rectangle as a whole, then subtracted by the area for each triangle here, 1, 2, and 3. So then no matter how big the polygons is, then I can always do that. And then that can be simplified by using the shoelace or shoestring method. So the shoelace or shoestring method in this sense, for example, is that I'll put it as a formula over here, is that the area is half times this is called the determinant, which is something that you will learn only in vector matrices in some time later. So I will have to write it either in anti-clockwise coordinates, or clockwise, so it's your choice. So if in the case of this, I'll put it this way. It's a clockwise direction, so x1, y1, x3, y3, x2, y2. So then bear in mind that means that I can also put it as half x1, y1, x2, y2, x3, y3, right? So the entire clockwise direction. So it's up to us. Now the thing is, the way it is written is not actually like this. I have to add another one, which is go back to the original coordinates, which is x1, y1, here also x1, y1. And then the way we do it is simply as this. So I have to multiply this pair. So it's a half times x1, y3 plus x3, y2 plus x2, y1. So I just have to multiply that way. But then I also have to multiply the other side. This, and this pairs. But then when I multiply this one, I should put a negative sign. x3, y1 minus x2, y3 minus x1, y2, and so on. So then that's it basically. So if this value is negative, then because of the modulus sign it becomes positive, then you get the result. So whichever method that you're using, anti-clockwise or clockwise direction, it will end up with the same result, and it must end up with the same result. So let's get through an example. So you can pause this video and then try to do it first by using the shoelace method, the shoestring method. And I'll show it here for you. So the area here will be half. Shoelace method, I'll put it -2, 3. Let's say I'll put it 0, -4, 5, 6, and then I'll go back to -2, 3 again. Right? So then half, I'll do it slowly. -2 times -4 plus 0 times 6 plus 5 times 3. So you see I'll do it this pair, right? And then I'll do another pair on the opposite direction. So -3 times 0 minus 5 times -4 minus negative 2 times 6, like this. So if it's too fast, then you can slow down, or you can pause it one by one, and you'll see it one by one. Okay. So and then half, modulus, multiply by 1, 8, 0, 15, and then another 0, 20, and then 12. Right? So then you see we'll get 20, 40, 55. So half 55, you got 27.5 square units. So then the way I do it here is I put the direction this way, right? And this is anti-clockwise. So you can try it on your own. How if you're using the clockwise direction? Will you end up exactly with the same result? So you can try it first, but then based on the trial that I have tried to do, I've made, the difference for clockwise is that instead you will get half modulus negative 55. So then that's why it's really important for you to put the modulus sign. That's to ensure that our result will always be positive. That's it. So there's another question here as well. You can try it on your own. You can pause this video. You can try it on your own, and you can we can discuss it in the class. In another handout, you can see the detail of how we derive the formula, the shoelace or shoestring method. Then you can, if you're interested, you can study further. And then the way we write the shoelace shoestring method, it doesn't have to be written horizontally like this, but we can also write it in the sense of half. It depends on how you write it. 3, 0, negative 4, 5, 6, negative 2, 3, and then it works pretty much the same. But I just prefer it this way because it looks more convenient to me. That's okay. So thank you. So I hope that's understandable. If you're not, then you can try to repeat the video again, look at the resource, look at further handout. Thank you.